Find the derivative of fx is equal x cubed. So here we need to use the definition, which is f prime x is equal limit of fx plus h minus f of x over h when h approach to 0 to find the derivative of this function. Our function is f of x is equal x cubed. So we use the definition f prime x, it is equal limit of f x plus h minus f of x over h when h approach to 0. So now let us substitute in this definition fx plus h. That means we go to the function x, replacing any x by x plus h. So it will be x plus h cubed minus f of x, that means x cubed divided by h. We evaluate the limit when h approach to 0. So this will give us limit. Now we have x plus h all cubed. So this will be x cubed plus 3x squared h plus 3x h squared plus h cubed. So x plus h all cubed will be x cubed plus 3x squared h plus 3x h squared plus h cubed. Then minus x cubed, and we divide all by h. Now we will simplify. So here we have x cubed, we cancel it with minus x cubed, and this will give us, it is equal limit. We have seen here we have 3x squared h plus 3x h squared plus h cubed, so we can take x as a common factor. So we left with 3x squared plus 3xh plus h squared all divided by h. We evaluate the limit when h approach to 0. Now we can cancel also h with h. So we left with, this will give us, it is equal limit of 3x squared plus 3xh plus h squared when h approach to 0. So since this one is a polynomial, now we can replace h by 0. So this will give us 3x squared plus 3x multiplied by 0 plus 0 squared. So this will give us, it is equal 3x squared. So the derivative of x cubed will be equal 3x squared. So the derivative of f of x is equal x cubed is given by f prime x, it is equal 3x squared. So example number 4, find an equation of the tangent line to the graph of fx is equal x cubed at x is equal half. So to find an equation for any line, either we need 2 points or we need 1 point and a slope. Since here we have at a point x is equal half, so we can find one point, and also we can find a slope using the definition of the derivative. Then we will replace x by half. So first we will find the slope, then we will find the point, then we can find the equation of the tangent line. Seeing that f prime x, which is the derivative, is equal 3x squared. And to find the slope of this function, just we need to find the derivative, then replacing x by whatever x is given. So here f prime half, to find the slope, or if we write here untangent, it is equal f prime half, which is equal 3 multiplied by half or squared. So this will give us 3 over 4. So now we have the slope, just we need a point, another point. So we have x is equal half. To find the second or the y coordinate, just we need to evaluate what is f half. So f half, it is equal half power 3. This will give us 1 over 8. So the y coordinate is 1 over 8. So now we have the point of tangency. So from here the point of tangency it is half and 1/8. Now we have a slope, we have a point, we can write the equation of the tangent line. So the equation, the tangent line at x is equal half is given by y minus y1, which is 1/8. So y minus 1/8 is equal m, which is the slope, and the slope we have seen it is equal 3/4 multiplied by x minus x1, because you know that the equation is given for any line. We know the equation, it is given by y minus y1, it is equal m multiplied by x minus x1. We are here our m, and this one is x1, and this one is y1. So we substitute in this equation to find the equation of the tangent line. So y minus 1/8 it is equal 3/4 multiplied by x minus half. Or you can rewrite this equation as equal, we'll move minus 1/8 to the other side, so we'll have 3/4 multiplied by x, so it will be 3/4 multiplied by x, 3/4 multiplied by minus half, and we add 1/8, this will give us 1/4. So this is the equation of the tangent line passing through the point half 1/8. Here we have a graph of the tangent line of the equation y is equal x cube at the point x is equal half. So where the blue one is y is equal x cube, and the red one is the tangent line, which is passing through the point half 1/8. So example number 5, find the derivative of f(x) is equal 1/x. So again here we need to use the definition to find the derivative. The derivative, we use the definition f prime x is equal limit of fx plus h minus f of x over h, evaluating the limit when h approaches to 0. So this will give us fx plus h, that means we go to the function x, replace any x by x over h. So 1/x plus h minus f of x, which is 1/x, we divide all function by h. This will give us limit. So here we have 1/x plus h minus 1/x. I multiply this one by x over x, multiply this one by x plus h, divided by x plus h. So this will give us x minus x plus h divided by x plus h multiplied by x, all function divided by h. So here we have also limit. So from here I multiply the first part by x over x, and the second fraction by x plus h over x plus h. Since I have the same denominator, then I can add these two functions. It will be x minus x plus h. So here we have limit x minus x plus h. This will give us x minus x will cancel, so we left with minus h divided by, here we have x plus h multiplied by x divided by h, so I can write it like h multiplied by x plus h multiplied by x. I can cancel h with h, so this will give us limit minus 1/x plus h multiplied by x. We evaluate the limit when h approaches to 0. So now by direct substitute we'll get minus 1/0 plus this one x will remain the same, just we need to replace the h. So h will be 0, x will be the same. So here we have x plus 0 multiplied by x. This will give us minus 1 over x squared. So the derivative of y is equal 1 over x will be minus 1 over x squared. Here we have some notation. The following denote the derivative of the function f or y with respect to the variable x. So f prime x dy over dx, y prime x dx y, all these represent the derivative of the function f with respect to the variable x. The value of the derivative at a number a is denoted by f prime a dy over dx when x is equal a, or y prime a or dxy when x is equal a. So this one represents the derivative at a point a. And we have differential operator d over dx or dx. We differentiate this function with respect to x. We write it d over dx of x squared plus 2 which is equal to x. يعني لو صادفنا مثلا f برايم x أو dy over dx y prime x dxy, that's mean all the same meaning. We need to find the derivative. If you find f prime a dy over dx when x is equal a, y prime a dxy when x is equal a, all of these represent that you find the derivative at a specific point which is a. Differential operator, that means we differentiate our function with respect to x. So d over dx, that means we differentiate this function with respect to x. Also, we called a function is differentiable everywhere if it is differentiable on minus infinity to infinity. So if you can find the derivative of your function at all value in the real numbers, that means this function is differentiable everywhere. Also, a function is differentiable on an open interval a to b if it is differentiable at every number x in the open interval a to b. So if you can find the slope or the tangent for any value in this open interval, then you call this function is differentiable on the given interval. And all we have also a differentiable on a closed interval. So a function is differentiable in a closed interval a to b if it is differentiable at every number x in the open interval a to b, and so in addition to differentiability in the open interval, f prime a from right should be equal limit of fa plus h minus fa over h when h approach to 0 from right, and f prime p is equal limit of fa plus p plus h minus fb over h when h approach to 0 from left. So the right hand derivative and left hand derivative should be exist. So a function f is differentiable at a number c in the interval a to b if and only if the derivative at c from right is equal the derivative at c from left. So three types of differentiability we have seen: differentiable everywhere, that's mean differentiable at any number; differentiable in an open interval, it will be differentiable at any number inside this interval; differentiable in the closed interval, if it is differentiable in the open interval plus these two cases. And if we said that the function is differentiable at a point, that's mean the derivative at this point from right is equal to the derivative at the same point from left. So then here we have something which is called horizontal tangents. If y is equal f of x is a continuous at a number a, and f prime a is equal 0, then the tangent line at the point a, f of a is horizontal. So if the derivative of the function at the point a is equal 0, this tangent line is a horizontal. And we have seen that in example 1 and 2, the value of the derivative of f prime x is equal to 2x of the function x squared plus 2 at x is equal 0, and f prime 0 is equal 0. Thus the tangent line to the graph is horizontal at the point 0, f0 or 0, 0. So if the tangent line is horizontal, that's mean the derivative at this point is equal 0.